Okay. Molly, I'm going to ask you to keep an eye on the waiting room. I think we can close it now. I'm going to make you a co-host as well. And Terry, I'm going to make you a co-host. Okay. Well, I'm just going to say welcome, everybody, to this lecture with which is going to be presented by Terry. And I'm going to just let Terry start, basically. I mean, okay. Hopefully you all know who he is and why we're here. So, yeah, I'm just going to get on with it.
Okay, just going to do the difficult thing of sharing the screen. So let's see if that works. Is that working? Thumbs up, Michelle, if you can see the slide.
Yes, we can see the slides, Terry. Thank you.
Excellent. Molly, are you looking after the waiting room? Okay, great. All right, well, welcome everyone. Very nice to see you. Well, I was hoped to see you after when we get into the discussion and questions. I aim to leave some time for discussion questions at the end, and we can go beyond the hour if we need some bit of extra time. So the title is a bit strange. You might think it's a bit strange. I think it will become clear as we go on. This is going to be a general introduction to global warming and climate change. So I will then narrow it down a bit to the effects of climate change, and so you can relate it much more to what governments should do. And I'll have some challenges on that later on. So what I would like to do is, if there's something that is not clear in one of my slides or what I say, I'd ask you to put your hand up there, because it's much easier to clarify it right there with that slide. So if you just use the raise hand function, Molly, are you staying the whole time? Maybe you'll be able to help me to see that if I miss it. So do interrupt if it is just a question to clarify a particular slide. Otherwise, comments or questions at the end. All right. So the first slide, this is the climate zones of the Earth. Now you'll see there's only 12 of them. And this is produced by the IPCC, which I'll mention again later. And so the key point about this is that the Earth has a very recognizable set of climates. They are very much affected by latitude. That means the horizontal divisions in the Earth. And you can see, for example, you have the tropics around the equator. Here, much of the tropics is tropical wet. A lot of it was forest, some still is forest. So you've got this band around the equator here. And as you get nearer to the poles, of course, it gets cooler. So you have these cool zones here. And once you get up into Siberia and Canada, you have what's called the boreal moist climate zone and dry climate zone right up here on the edge. We will be talking a lot more about the Arctic zone later on. But the key point for this map, these climate zones have been known for at least 100 years. In other words, very early on, meteorologists, climatologists realized that the Earth has a very regular set of climates. And if I was in the class, I would ask for some volunteers to name a place on the Earth, maybe a city, and a day of the year and the time of the day. And a good meteorologist, that excludes me, would be able to say what the expected weather is in that place on that day at that time, because it is so regular. Okay, they're known, they've been known for years. Now, the problem with global warming is that it is changing these climates. So what we normally expect to find in these different color zones is changing. So are the zones shrinking? Are they moving? Are they expanding? What is happening to them? And so what you can grow in one place, which you could grow as a crop before, will you be able to carry on growing it as these zones, these climate zones, alter with global warming. So that's kind of the first starting point. I'm going to go fairly fast, and some of these slides are going to be for reference, for you to keep for reference, and we'll share the slides. I'll put them in the chat box nearer to the end for you to download. So we're going to do this introduction. What is weather and what is climate? What's the difference between them? A very simple way of thinking about it is weather is what you get. It's what you can see outside the window right now. And the climate is what you expect. So on any of those places on this earth that I mentioned, if you chose one of those places, you would be able to say, as a climatologist, that on that day in Addis Ababa, let's say the 23rd of July, you would expect with 80% certainty that the temperature would be top there and bottom there. And you would be able to define the range of what you expect with a very high degree of certainty. And the same for rainfall. So the climate is what you expect. The weather is what you actually get on the day. The temperature, of course, varies. It isn't fixed. It is, the weather is variable, but the climate is fixed. The climate is what you get in that location. So global warming is causing climate change. This is the relationship between them. The Earth is warming up, and that is what is leading to the changing climate zones and the changing climate in each part of the Earth. And so what was previously expected becomes disrupted. Now, the reason for this is because humans have been emitting greenhouse gases for the last roughly 140 years since we've been burning coal and then later oil and natural gas. And we've been doing various other things as well, which have changed the caused global warming, which is changing the climate. And we will come to those in a minute. So primarily what we're interested in is why this is happening. Now, the greenhouse gases, I will be explaining what they are in a few minutes. And the sources of greenhouse gases are principally from those fossil fuels, coal, oil, natural gas, but also from farming, because some types of farming produce greenhouse gases, and some types of fertilizer lead to greenhouse gases. Deforestation leads to carbon dioxide being released. And there are some natural sources, which we will see later on, natural sources of methane in particular, which are being released because of human activity. In other words, normally they would be natural sources of methane, but now they're being increased in very large quantities because of human-induced global warming. And the key to all this is actually understanding what's called the Earth's energy balance. So if you imagine the Earth is a sphere, Molly, just give me a thumbs up if you can see my hands held roughly in the shape of a sphere. Yes, okay. So the Earth is a sphere and the sun is over here and the Earth goes round the sun on an annual basis. It has various perturbations to that, which we don't need to go into. So basically what we're interested in is how much energy comes into the sun, into the atmosphere and the oceans, and what affects the balance, because normally what comes in from the sun is perfectly balanced with what goes out and is reflected out into space from the Earth, and the Earth acting as a reflector and as a radiator. So that balance is disrupted by us putting stuff into the atmosphere which is not natural. And that is the human-based sources of those so-called greenhouse gases. Now, those greenhouse gases, if they weren't there, we would not be alive. The Earth needs a certain amount of carbon dioxide, otherwise life could not exist on Earth, because it raises the Earth's temperature in order that life exists. Unlike Mars, which has no or hardly any atmosphere and is extremely cold. So we need those greenhouse gases for life to exist on Earth. But we are increasing them, and you will see exactly how much in a minute. So the Earth's energy balance is how much of the sun's energy arrives on Earth, how much is retained by the oceans and the land surface, and how much is re-radiated back out into space, because the Earth acts like a radiator. Some of the energy also gets reflected, for example, by clouds and by snow or ice. And that effect is called the albedo effect. Ice has a very high albedo. That means it reflects a lot of the Earth's, of the sun's energy back out into space. which means that if ice and snow cover on Earth is melting because of human interference, then that is increasing the likelihood that the Earth will absorb more of the sun's energy and get hotter still. We'll come back to that. Changes in what is on the land, including, for example, deforestation, also affect this energy balance. Now, in response to this, for at least 30 years, in different political forms and scientific basis, we know that we have to reduce the emissions. So the word for that is mitigation, mitigating the emissions to reduce how much greenhouse gases is discharged and to reduce the deforestation. So that's one response that humans have realized we have to do. So this is about the reduction of emissions. The other one is we have to prepare for the inevitable, because the Earth is getting warmer, will get even warmer, and we have to adjust to that. So human systems, every single person, household on this Earth will have to adjust to the fact, and the word for that is adaptation, to the fact that the climate is, the Earth is getting warmer. This is a very simple representation of the Earth's energy balance. You can see the sun's energy is coming in yellow. In the Earth's atmosphere, which is all of those spheres, you've got those gases there, which are the greenhouse gases. And depending how much of those gases is in the atmosphere affects how much the Earth retains heat rather than it being re-radiated out into space. So the more that we add these molecules of these gases into the atmosphere, the more it will heat up the Earth, the atmosphere, and also the oceans. Now, this atmosphere is actually tiny, tiny, thin layer. So if you were to imagine a sphere as big as I can draw on the camera here, then the atmosphere would be thinner than a sheet of paper on the edge of the Earth. So that's the kind of level of the atmosphere that we're talking about, in which all of this process is going on, which is so dangerous. Now, here are the ways in which, sorry, I put that in by mistake twice. Right. Here are the responses to what is going on with global warming, the impacts. So the first was the realization from the late 80s that humans would have to reduce our emissions. We would have to mitigate them from fossil fuels, and then later it was realized it would have to come from agriculture and deforestation as well. The second response, and that red is the realization about 10 years ago that forests were contributing, deforestation was a very big problem and had to be reduced as well. The second main intervention is adaptation, which means preparing to deal with the effects of climate change. Now, I'm going to emphasize that there are 4 kinds of effects or impacts of climate change. And it's wrong to see climate change as just one thing. It is 4 overlapping, but also should be considered as separate things. And I'm going to explain that as we go along. Then this box is what's called loss and damage. Now, the reason this is here is that around 10 years ago, there was a campaign and a realization that not everywhere on this Earth can adapt. There will be some severe effects of climate change, which humans will not be able to adapt to. So this will cause what's called loss and damage. And this became another big argument in the international negotiations, in which some countries were claiming through this campaign that the rich countries that were by and large the main causes of global warming should be compensating poorer countries for the loss and damage to which they cannot prepare, for which they cannot prepare. So we can come back to that as well. So these are the 4 major negotiations that are going on in the climate talks, which happen each year or almost every year in the COPs, the Conference of Parties. So this is the UN system. The next one, as you know, is in November, supposedly in Glasgow in Britain. And you probably have all heard of the Paris COP, which was in 2015, which was the last major round of negotiations on this with the so-called Paris Agreement. So the key actors in climate change is the UNFCCC, which deals with the politics. This is the legal body in international law called the United Nations Framework Convention on Climate Change. This is one of a number of international treaty processes which is trying to deal with climate change. There are others, there's a biodiversity one as well, but we're focused on this one. And they organize the annual conference of parties. Party is simply a legal term, meaning it's a signatory or a member of the negotiating group for the treaty. Then there are other negotiations held alongside for REDD and loss and damage. Then the second key actor is the IPCC, which is the science part of it. This is the Intergovernmental Panel on Climate Change, which is a body of around 2,000 scientists from all of the member countries, which meets and discusses the publications that are coming out on different aspects of global warming. And they then provide reports which advise the political system in the discussions for the negotiations. So they provide the scientific advice. They aren't doing the research, they are summarizing the research done by thousands and thousands of others. And they produce these reports. The next one is the 6th report, which is due out in the next 2 years. And these are all free online. You can Google these. They are extremely thorough. They get better and better as they get more and more experience. And they have 3 working groups looking at the science of climate change, adaptation, how to prepare for climate change, and then how to mitigate, reduce the greenhouse gas emissions. So that's the international process that's going on. Now, the greenhouse gases, I'm not going to go into detail. There's a list there for you. You might be surprised that water vapor is a greenhouse gas. We are all surrounded by water vapor. More of it's a humid day, less of it's a non-humid day. But water vapor is a greenhouse gas. Now, it has been increasing in the atmosphere because of global warming, because warming evaporates more water. So that evaporated water is in the atmosphere. So we have produced more water vapor as a human-caused greenhouse gas. Then there's methane, which is, as I mentioned, comes from agriculture as well. So paddy fields produce a great deal of methane, and livestock, especially cattle, produce methane from both the front end and the back end. And as you probably heard, the rapid expansion of beef farming around the world to feed for rising incomes means that there is far more livestock producing methane around. I'm not going to mention the others, but that's basically the list. Now, that we do have a problem because they're called greenhouse gases, and most of the world has no idea what a greenhouse is. So a greenhouse is that. Now, I'm sure you all know what a greenhouse is. There's a fine crop of strawberries here. And you can see some strawberries down at the bottom there. So a greenhouse can be plastic or glass. And this is the metaphor for global warming. Basically, the atmosphere is the glass or the plastic. And that atmosphere retains the heat inside. This is the Earth's atmosphere, the inside of the greenhouse. And so this was realized more than 100 years ago, that the carbon dioxide in the air keeps the atmosphere warm and enables life. I have a problem with this, which is why I'm showing you a picture of a greenhouse, because probably 80% of the world's population has not got a clue what a greenhouse is. So I prefer the term blanket gases. Almost everyone on Earth knows what a blanket gas is. And so this may help them to understand that a blanket is an added layer of insulation which keeps the atmosphere warm. So this is a key part of how we understand what's going on. And we have all of these terminologies and buzzwords and so on in global warming, which is a big problem. This is the Earth's atmosphere. It is the largest part of it is nitrogen, which has no effect on the atmosphere. Oxygen has no effect, but here in this tiny sliver here are the greenhouse gases, which have an enormous effect on the Earth's atmosphere if they increase or decrease. So that's where we are worried about, is these very small amounts of gases in the atmosphere that affect the temperature of the Earth by upsetting the energy balance. Now, where is it coming from? This is where the carbon dioxide is mostly coming from, and also methane. So you can see most of it comes from producing heat and electricity and from industry. A lot is coming from agriculture and deforestation and so on. So this is just to give you an overview of where it's coming from. And this is carbon dioxide on its own. So on the right-hand side, don't worry about this too much. This is how much we've emitted in billions of tons over the last nearly 200 years. This is the side to be looking at, which is this pink side here. You can see the scale goes from 260 parts per million up to 420 parts per million. You can see that since the start of the industrial, or here, this point here is usually taken as the start around 1870, the amount of carbon dioxide in the atmosphere has gone up from 290 parts per million to well over 400 parts per million. And that is all caused by humans. So this is what you could call the smoking gun. This is the carbon dioxide. This does not include the methane. This is just the carbon dioxide come from burning, mainly from burning fossil fuels, plus some from deforestation. So this enormous increase, I need to give you a context for it. So this is the last million years. So the highest point in the last million years of the carbon dioxide was here when it was 300. These ups and downs here are the ice ages, which I hope you've all heard of the ice ages, which happen periodically, okay? We are still emerging in a sense from the last ice age, which ended around 15,000 years ago. But look here at the carbon dioxide. It has shot up way beyond the highest level that it's ever been for a million years. And the only explanation for this is human action. So this here is the problem. In that square there, it is now around 414 parts per million. And this is where it's coming from. Now, this is not a name and shame thing, because I'll explain. You can see that China is now the world's largest emitter. Second is the United States, and the different parts of the world are listed here. Now, why is it not a name and shame? This is a fundamental problem in the UN negotiations, because the measurement goes on the basis of the country and not who is causing the emissions. And I'm not going to have time to say much about it, but the problem is China here, which is the largest emitter in the world as a country, actually, they are my emissions. If I buy trainers or a shirt or a computer that is made in China, those are my emissions. They are not Chinese people's emissions. And this is the key problem, is that over the last 20 years, China has become the manufacturing zone for rich people around the world, for the United States as well. As you know, Trump arguing about the balance of trade problem. So this is grossly unfair in the sense that actually, if you counted the emissions of who is causing the emissions, they are our emissions in the rich countries where we are buying stuff that is made in China. How is carbon dioxide measured? It's actually measured on a mountain in Hawaii. And that mountain has a box on it, and that box is able to measure how much carbon dioxide is in the air. And it was put on Hawaii on this mountain because it's not near to any sources of carbon dioxide. So it measures the actual background level of carbon dioxide. And here you can see that it's gone up from 1960, around 310 parts per million, to well over 400 right at the moment. So this rapid rise in carbon dioxide because of human action. There it is on the Hawaiian island there. This one is from Extinction Rebellion, which I hope all of you have heard of. And I think this is particularly useful because it shows how this has gone up. It's the same graph for the carbon dioxide, rapid rise. And here they put all the talking. Now, since the first IPCC, since the first treaty on global warming, 1992, at the World Earth Summit, it was called, can you see none of this talking has done much to reduce the emissions of carbon dioxide? So I think this is a very, very powerful statement. And we know from measurements recently that the emissions are still going up. They're going in the wrong direction. They're not going down. Although there is supposedly an agreement that by 2030, all countries in the Paris Agreement will reduce their emissions to zero. It's extremely unlikely that that's going to happen. And because of that rapid rise in carbon dioxide, the Earth is heating up faster and faster. So if we look at the heating graph over the last 150 years, it's relatively flat. If we look at the last 40 years, it gets steeper and steeper. So this is the graph superimposed onto the temperature spots. The black dots are the actual annual mean temperatures. So the rate at which the temperature is going up is faster and faster. Now, if we look again over the last 1,000 years, you can see that the temperature, this is a temperature graph, is relatively stable, okay? These gray things are the actual measurements. Now, of course, there were no thermometers before here. So all of these measurements are made using surrogate data from tree rings and from ice cores. Here is the rapid jump in the temperature here. And here is what will happen if we do not reduce our greenhouse gas emissions. The worst scenario pushes the temperature up to 5 degrees higher than it is at the moment, okay? What we are hoping is that it will be restricted to 1.5 degrees above what it is at the moment. Now, to give you an idea of where we are on this, when we started, we have a master's course on climate change at IDS, as you probably know. When we started that course 10 years ago, the Earth's temperature was 0.7 degrees centigrade warmer than it was 100 years ago. Okay. It is now 1.1 degrees centigrade warmer than it was 100 years ago. So in just 10 years since we've been running this course, the Earth's temperature has gone up on average by 0.4 degrees. So this is the kind of scale we're looking at. Now these here, these bar lines and these here, these zones here, is because once you get far into the future, it's difficult to be very accurate about what the scenario is going to produce. Okay, so here are two scenarios. This is the red one is business as usual if we don't reduce emissions. If we do have aggressive reduction of emissions, for example, under the Paris Agreement, if that succeeds, then the Earth's temperature begins to flatten off, we hope. Okay, and we hope that it is no more than 1.5 degrees. It doesn't look like we're on track for that at the moment. So this is why we need to support organizations like Extinction Rebellion to call attention to the fact that what's going on at the moment is not nearly good enough. I'm going to go through these fairly quickly because you can look at these afterwards. One main point to take from this is that the average temperature, it varies enormously across the globe. So if we compare the temperature over the last 50 years with the baseline here, we can see that most of the heat is coming into the Arctic and quite a lot into the Antarctic. Okay, so that the average temperature increase is distributed very unevenly over the Earth's surface. And we will see some of the consequences of this heating in the Arctic a little later on. And again, I'm going to move on from this. This is there for your reference. If you would like, well, I hope you will find it useful afterwards. This one also for your reference. On the left-hand side is the, at the top temperature and at the bottom rainfall, if we control emissions. So by the end of the century, this almost everywhere on Earth will be between 1 and 2 degrees warmer, and the Arctic will be much warmer. If we don't control emissions, and it's what's called business as usual, then almost all of the Earth goes up by at least 4 degrees, and the Arctic region goes up by 11 degrees centigrade. Now, that would be devastating. You can also see the rainfall patterns here, which are much more difficult to predict. And they're just to kind of stimulate you. And here is the explanation of them if you want to go into more detail. Now, I've been emphasizing that climate change is 4 different kinds of things. It isn't just one thing. It is wrong to think of climate change as just one kind of climate change. Climate change hits us. It hits us with more intense and or more frequent hazards, the H part. It hits us with increased variability, which I will explain later on. And it hits us with the T of trends. This is principally the rising trend in rainfall and temperature on the graphs that I've just been showing you. And it also hits us with so-called slow onset changes like sea level rise and glacier melt and biodiversity damage. Now, this all looks very neat and understandable, but one of our students a few years ago, when I was emphasizing that it's these 4 things, said, oh, I've got a much easier way to remember this, because climate change is actually shit. So this helps you to remember it much more. I hope that we've got these 4 kinds of problems. They do interact, they have some overlap, but I think it's really important to acknowledge there's these 4 things because they each require different forms of adaptation. The human response to them has to take into account what kind of effect climate change is having. So I'm going to go through each of these 4 things one by one, and I will have to speed up. They will be there for you as for reference. But the hazards will be changes in the frequency and duration of floods and heat waves and so on. And the climate change will make these worse in many parts of the world. Increased frequency and or increased intensity, not necessarily the same for each kind of hazard. So for example, tropical cyclones, that means hurricanes, typhoons, cyclones in South Asia, it is likely they will become more intense, that is more severe, not more frequent. So that's a really important thing to understand. But another thing to understand about this is that disasters related to this will become worse because climate change will increase the number of poor people, especially in countries that are already poor. So as climate change takes effect, damaging livelihoods and agriculture and so on, there will be millions more poor people. Millions more poor people means that they are more vulnerable to hazards. So it's really vitally important to understand these 2 sides of it. So this is why climate change will make disasters worse. It will increase the hazards, make them worse or more frequent, or both. It will increase the number of people exposed to hazards, and it will damage livelihoods to make people likely to be vulnerable to extreme events. So this is another important point, which is about attribution. We cannot easily say that this hurricane or this flood is caused by global warming. In fact, it's impossible to say that an individual event has been caused by global warming because it hasn't. Floods, hurricanes, droughts are all normal. What we do need to understand is how much of that can be attributed to global warming. So can we say that this hurricane was 30% worse because of global warming? And in fact, the science is beginning to get to the point where it can do that. With Hurricane Harvey in Texas a few years ago, they said it's 30% worse because of global warming. That means more rainfall, higher wind speeds, higher storm surge, and so on. But it is really, really important to understand that floods, hurricanes, cyclones are not caused by global warming. Surprisingly, some people think they are. So the attribution problem is really important to understand. If we look at trends, what are the primary effects of trends? Well, the rainfall are the main, and temperature are the main variables. They will change geographical extent. Rainfall may become more intense. So temperature regimes may be upset, greater humidity, less humidity, and so on. I'm really going to rush through these because I do want to leave a good time for discussion. Now, what we have to understand around this is that nearly half the world's population is directly dependent on the climate for their farming, for their livelihood is climate dependent. So this means that we have to take into account the needs of adaptation for almost nearly half the world's population. So the primary effects of the trends of rainfall and temperature are going to hit those people who are the farming population of the earth. Now, of course, everyone who is not farming depends on them producing the food. And so everyone else is dependent on how well they are able to adapt to global warming. So the primary effects are going to be on crop yields. Incidentally, that one there, fewer cold and frosty days. Warmer winters means that pests are now surviving more, not getting wiped out by the cold winters. So we'll come back to that in a minute. The zones where you can grow particular crops are shifting. Land use changes, impacts on forests, fisheries, corals, and the food web. And I'll look at this one for a minute. Changes to the diseases of crops in the field and after you've harvested them. What will happen to the different diseases that are affecting them? So, for example, many farmers around the world depend on coffee to give them a cash income. But in much of Central America and parts of Africa now, coffee plants are being affected by a virus called leaf wilt, coffee leaf wilt, which is having a very severe effect on their yields. And this is related to rising temperature. The trend, the primary impact of the trend of temperature seems to be related to the rate at which crops, coffee crops are infected with this virus. Livestock diseases may increase in some parts of the world. Forests are being hit by pests, which I'll explain again in a minute. And then there are the worries about human diseases which are affected especially by mosquitoes. Dengue, for example, seems to be related to global warming. And then the waterborne diseases, diarrhea, cholera in particular. We then might need to think about the effects on poverty and therefore whether or not people need to migrate. Sometimes they may also be displaced by a hurricane or a flood. So there are different forms of population mobility. But we do need to understand also that the concept of climate refugees or environmental refugees is extremely contentious and is, in my view, not valid. And I'll explain that again in the discussion if people want to come back on that. And the reason is because of attribution. We cannot attribute floods or hurricanes to global warming. So we cannot say that they are climate refugees or environmental refugees. This is quite an old map, but it shows some of the effects, expected effects by the 2080s of global warming on crops. You can see a reduction in most of the global south, a reduction of between 5 and 25% of the crop yields. Now that is going to have a devastating effect on people's livelihoods in those parts of the world, which already contain the largest proportion of poor people in the world. So secondary impacts, which I'm going to skim over very quickly because you can read these, and it's really important with global warming to look at the knock-on effects that come from, for example, here, temperature trends. What will be the additional problems that will arise from that? Secondary effects, again, which I would simply ask you to look at afterwards. One of those is at the bottom there is climate conflicts, which goes back to the climate refugees point. And again, we can discuss that. In my view, at the moment, there is no clear evidence that there are conflicts which are directly caused by global warming, by climate change. It may be a cofactor, but it is unlikely that climate change will actually precipitate of its own any conflicts. It will be in a cofactor with other factors. Forest fires, mentioning this because it comes up quite a lot. This is in Canada, west of Canada, 2018. So many fires, and partly this was related also to a pest called the pine bark beetle, which is now surviving the winters because the winters are warming. All of these trees have been damaged. They are going to be dead because of the pine bark beetle. And when they are dead, they burn more readily. So they are another factor in wildfires. The Arctic has had huge wildfires. Sweden has had wildfires within the Arctic Circle, so has Russia inside the Arctic Circle up there in the north, Moscow here. This town had to be evacuated because of the smoke from wildfires 2 years ago. Here in the Siberia, in the Arctic Circle, you've got these fires. The Amazon, which everyone talks about. Now, here is one of the first points I want to make about the dangers of misunderstanding climate change and global warming. Because although the fires were increased in numbers here, and you can see here, a lot of these fires are not related to global warming. These are fires which are normal agricultural practice, and I'm not going to talk in detail, you can look this up. These fires here, for example, are farmers setting fire to the crop residue to clear the land for the next harvest. Now, of course, when this land was cleared from rainforest, here you can see virgin rainforest here neighboring them. So when it was cleared, that of course was a very bad thing. But many of these fires here are not wildfires burning the rainforest. They are farmers' fires, which are happening as part of the normal crop production cycle, as they are in many of these places around the world. So in many of these places, these fires are not wildfires. They are in these parts of Africa, around the Sahel, in the Amazon, in Madagascar, here in Asia. These are where farmers use fire as part of the normal crop production cycle. And this is really important to understand, that we do not virtue signal around climate change and attribute things in the wrong way. The slow onset problems are, of course, sea level rise, which will affect mostly coasts and deltas, glacier melt, melting of polar ice, which is sea ice, which will lead to the extraction possibly of more oil and gas and open up the polar route for navigation. Changes in the ocean atmosphere interaction, which can be serious. Ice cover, of course, when it melts, leads to ocean heating, and so on. I'm going into a lot of detail here. If you spot something you're not clear about, do ask a question. Of course, there is also the ocean acidification problem, which is causing damage to fossils and therefore to the food web, because that damages the bottom layer of the food web, and loss of biodiversity, which is already suffering anyway from other human action. Here is the ice, the sea ice, floating ice on the sea, and the loss since 1981. So this was 1981. It is now restricted, and it's getting less each year. And as this ocean is not covered by ice, it warms up much more quickly, and it warms the Earth's atmosphere, and especially it warms the area around the Arctic as well. This is what happened on this island, which is a Russian island here, because the polar bears require ice to hunt. They're hunting for seals. And when they could no longer hunt for their natural prey, they invaded the town and the rubbish dump a few years ago. I don't know if this is still going on, but this is one of the other consequences of the damage to the ecosystem. This one again shows the decline in the ice on the Arctic Ocean. But what I want to draw your attention to here is that all of this zone here is what's called permafrost. It is permanently frozen land. Now, this is shrinking. So this area is no longer going to be frozen. The permafrost is shrinking towards the pole as these areas warm up. Remember that the warmest part of the world is the Arctic region. This is the part of the world we're looking down on the North Pole. This is the part of the world which is warming up faster than anywhere else, and it is melting the permafrost. Now, if you put your building on what you thought was solid ground, they now fall over. So this is in Alaska, and this is the forest that's falling over. They're not dead, they're just, their roots no longer hold in the soil because the soil is melting. This is in Siberia, where buildings are falling down because the ground underneath them is melting. And what's coming as well as it melts is methane gas coming out of the ground, because this this part of the world is very boggy, but if it's frozen, that's all right. The methane stays there. But because we've warmed up the atmosphere, the methane from all this wet land here in these lakes is bubbling up as it melts, and you can burn it. If you look at this video, it's quite impressive. But basically what she's doing is trying to get some measurement of how much methane is coming out from the Arctic region in this permafrost zone. Now, the sea level rise is mostly coming from the water expanding. As the water in the oceans gets warmer, it takes up more space. And so the sea level rises, it can't go down, so it has to go up. And then, of course, it spreads over the land. So it's roughly 42% from thermal expansion of water. Warm water is bigger than cold water, and from melting ice on the land. And this is the projection of sea level rise depending on whether or not we prevent more carbon emissions. You can see that even on the low emissions scenario, this is if we abide by the Paris Agreement and come to zero emissions by 2030, then we still have expected a meter sea level rise, or between 0.3 meters and 1.2 meters, which is going to be really serious for deltas and coastal regions. Greenland ice loss is one of the main sources of that, the melting ice. The later figures for that is 244. There are some really scary videos to watch on YouTube if you want to. This is the amount of gigatons per year that is coming out now on average. You can see it's gone up. It is now nearly 7 times more than it was 30 years ago, the melting of the ice. This is Antarctica. The main area that is being worried about is this area here, from which you might remember a few weeks ago, a huge iceberg broke off that was larger than New York and traveled northwards. The icebergs aren't so much of a problem. It's that the ice holds back the land ice, which melts. So this melting land ice, sea ice, is holding back the land ice. And I can't stop to go into more detail here. Now, sea level rise is often mentioned as a huge problem for countries like Bangladesh and Vietnam. So this is actually the altitude above sea level of the Bangladesh Delta. Now, this is all a delta of the 3 rivers that come down, the Ganges, the Brahmaputra from Tibet, and the Meghna from here within Bangladesh. All of this is mud and soil and salt and sand, sand and rocks deposited from the Himalayas. So basically, this is the Himalayas eroded by these rivers over thousands and thousands of years. And it is naturally low-lying. But you can see there's not very much of it that is only 1 meter above sea level. So the idea that Bangladesh is going to disappear into the ocean is extremely misleading. I'm not saying it's not a problem, but we need to think about what are the problems already for this coastal region, which is basically saltiness, salinization, which is, a lot of it is not related to global warming. Now, of course, there should be concern about this, especially if sea level rise is much faster than expected. But we need to get an understanding of this, and I'll come back to this at the end. This is the Mekong Delta, almost all of which is only 1 meter above sea level, so it's much worse than Bangladesh, and the salinization problem there as well. But in both deltas, the problem to a large extent is control of the upstream of the rivers. So the Mekong upstream, I believe, has 66 dams on it that basically prevent the water from getting to the ocean, and therefore that means that it is, about that, that the ocean saltiness pushes in, so this area becomes salty because the fresh water is not pushing the salt out. So there's a big salinization problem here in the Mekong Delta and many other deltas around as well. Now, the other problem here, and many deltas, is that it is subsiding. It has natural subsidence, plus humans are extracting water from under it. So it is sinking because of a combination of natural factors and humans extracting water, which means that the delta is sinking as sea level is rising. So a lot of the problems are not to do with sea level rise, but the way humans are affecting the balance of the delta. Glaciers melting. I'm going to skip through these very fast. You can see before and after. So this is over 100 years. All of that ice has melted. Here in Switzerland, the left hand was only 70 years ago. All of that's melted, you see on the right. This one in Argentina, that whole foreground is now water. All the ice is gone. This is in Alaska. Scary stuff. The I of SHINT is increased variability. And I think this is actually not looked at nearly enough in terms of the problems of global warming. What I mean by increased variability is that you do not get the seasons that you normally get. The rainfall and the temperature come in unpredictable ways. So we're not talking about the nice temperature trend or the nice rainfall trend. If it was like that, you knew the temperature was going to go up, let's say by ½ degree in 10 years, you would choose different varieties of crops which might tolerate that temperature. What happens if it's variable? And especially what happens if the rainfall is not a neat trend, but actually goes up and down? So this is the problem. So in parts of Africa, you have 2 rainy seasons like this. Now, this, of course, is averaged out. They never, ever get it neat and tidy like this. I do want to make that point. This is the average of what you get in the 2 rainy season parts of Africa. What happens if it comes like that instead? This is where there is no increase in the total rainfall, but it comes in lumps. So this is what may be happening in parts of Africa, that the rain comes in this intense period here. You have a longer dry period in between, which means that very, very difficult to farm. And these intense periods of rain can cause floods and landslides. So this is one possible thing from a change in the distribution, increased variability. But what happens if it comes like this? When there's no season, there's no rainy season anymore, the seasonality is disrupted. So this, you may get the same as the average amount of rainfall, but if it's delivered like this, then agriculture is extremely difficult and your crops are not going to grow. Sorry, this one seems to have come in by mistake to repeat. I'm sorry, I've got that in there a second time. We're nearly at the end. Now, what I want to do is to illustrate the relationship between the SHI and the T, or at least the HI and the T. This here is a representation of a world without global warming. So this line here, let's pretend it's rainfall. So this is the average rainfall over, let's say, about 30 years. This yellow line is actual rainfall for each year, okay? And this dotted line is the area within which you can cope with the climate that you've got. Your resources, and of course they will vary for each household, those resources are what enable you to have a decent livelihood. Only twice in this period of 40 years have you had a flood and a drought. So you can cope with that, because if you have good years in between, you can cope with a few bad years, okay? What happens when you have global warming? Let's say here, it is a rise in rainfall, but it's also an increase in the variability of the rainfall. It's going up and down, much more jagged. And here you get more extremes. So the H, you get more H. This is the T. The T is not the problem. The problem is the H, where it goes beyond your capacity to deal with it, and the fact that it is in extreme variation. And so what you need to deal with climate change is to have an envelope which is bigger. So you need to expand it through what we call adaptation, so that you can deal with the trend here, this trend line. You can deal with the H, and you can deal with the increased variability. So your resources enable you to do that. Now, how do people get those resources? How do they manage their livelihood to be able to expand what they've got now? Now, the argument has been all along that that would be money. I'm not sure it should always be money. We can have a discussion about that. It might be reorganizing the way in which society is structured to make it possible that resources are more fairly distributed, so that more poorer people have the resources that they need in order to adapt to climate change. And in effect, that is my my final point, which that was just a reference slide. If climate change is a magnifier or intensifier of existing problems, let's say of poverty and vulnerability, I think that there is a problem that some governments have captured the climate change narrative in order to evade responsibility for dealing with the problems that have been there for decades. So if it's a magnification of existing problems, they cannot be solved unless the underlying problems of poverty and vulnerability are also solved. So if governments start saying, oh, we're suffering terrible climate change, what are they doing about the existing problems? So this, I think, is a key way in which climate change narratives are being distorted in order that governments avoid their responsibility for taking charge of the poverty and suffering of their people. And I think many agencies, including NGOs, are falling into this as well. The work I've done in Bangladesh, loads of NGOs just pushing climate change, in danger of forgetting that the people already had huge existing problems, which now are disguised by focus on climate change. So that was why I had that title for the talk. We have about 10 minutes left before the hour is up, and I'm very happy to carry on beyond the hour. So I'm going to open it up now for questions and discussion. And I will leave the slides there if you need to come back to any, but I'm going to invite you to put your cameras on, because I don't think there's many of us that we can actually see each other, which will be very nice. And I can see some students from before, so it's very nice to see people who are students on our course. Let's open it up for questions and discussion. And do, if you feel comfortable to do it, do put your cameras on so we can see each other.
Yeah, and questions you can either put in the chat or you can say out loud. Thank you, Terry, for a really interesting lecture. It's really good for me to get the kind of basis of what you're talking about before we go into all the complex stuff, because it helps get my mind back into thinking about those things, because it's not something that I'm always working on. So it's always really good to hear from you, Terry, in that way. Does anybody have any questions? If not, I have a question. So
Hi, can you hear me?
Yes.
Oh, great. Sorry. Sometimes when I have my headphones in, it doesn't work. Hi, nice to see you again, Terry. Thank you very much for the fantastic lecture. I'm really sorry I'm going to have to jump off the call in a second because I'm at work at the moment, but
Yep.
I just wanted to say I definitely agree with this last slide. I mean, I think everything you said is very, very insightful, but yeah, this last slide in terms of climate change and its interaction with other issues that are pre-existing, I think that is something that's really, really key. And in the job I'm doing at the moment, actually, we bring in a lot of people to talk about different elements of climate change, and it's something that's come up a lot. We had a speaker in from the Seychelles a few weeks ago, and she was saying along those lines as well, that a lot of, especially Western countries, are ignoring some of the pre-existing issues that they may have very heavily contributed to in other countries that are then kind of being exacerbated by climate change. So I think that is definitely something that we have to focus on in our own work going forward as well.
Thank you.
Great, thanks, Danielle. Does anybody else have any questions or comments, or would just like to say hello to Terry if you haven't seen him for a few months?
I have a comment just because I have very limited knowledge of global warming, just the very basics. This was really informative and I enjoyed myself immensely.
Go ahead. Are we allowed to put files into? No, we can't put files into the. Hang on, let me get the chat box. So you wanted to ask something, Molly?
I just wanted to say that I don't have a very wide knowledge of global warming, just the basics. So this lecture was really informative and very enjoyable.
All right, good, good. I can't open up my chat box to see if I can put the file in for the slides.
Hi, Terry, can I ask a question?
Of course, yes.
Hi, nice to see you.
And you.
Yeah, first of all, the image with the polar bears was horrific, to be honest, to just see them in that environment where they're actually not, their environment is so destroyed that they're having to forage in areas that are just basically full of rubbish. So that's just a comment. I've not seen an image like that, and that was really quite distressing to see that. But my question is, from a sort of a local level or an individual level, I mean, we obviously hear about, well, you know, you can do this, that, and the other, but have you got any things that we could actually do ourselves to try to reduce our impact on climate change? I know it's only a drop in the ocean, but you know, it makes you feel a little bit more empowered if there's something that you can do individually. So I wondered if you had any hints or examples.
Well, I think they're all pretty standard now, reasonably well known. Reducing travel, not flying, they're all quite hard. The one I find toughest is reducing my meat consumption. I really find that very difficult. So we went to going half vegetarian actually a bit more than a year ago at home. We bought a house which has extremely low emissions. Unfortunately, it does have a gas boiler. One of the largest emissions that we have is from our homes, apart from travel. So insulation is good, but the government has just stopped the grants for insulation. And eventually gas boilers will be phased out. And I'm sorry that we didn't get that in our new home. Those are pretty much the basic things, actually. Cars, airline travel, but buying stuff. You know, there's carbon emissions embedded into everything that we buy. So being careful, reusing, repurposing, recycling is vital. I mean, we are almost at the situation in our household where we throw nothing away. Everything is reused or repurposed. So I'm rather obsessive about that. My partner gets a bit fed up with me for that.
Okay, thank you.
But I do want to also add a kind of a key political point to that you all know about how big business manipulates us. Mm-hmm. And you know how the tobacco industry manipulated around smoking, you know, the uncertainty of the science over smoking not being unhealthy. And then, you know, the fossil fuel industries did that over climate change. So they were sowing lots of mistruths, lies about misleading on the climate science. But one of their more recent tactics is to lead to campaigns which emphasize how individuals must reduce their own impact, as if the problem is going to be solved by individual behavior. And that is grossly misleading, because if it was taken seriously globally, there's less than 1,000 companies that produce the vast majority of emissions. If we had a tax on carbon where they burn fossil fuels, the problem would be by and large solved, because that would make everything much more expensive. We would then have, in some countries, you would have the tax and grant system, which McGibbon has advocated for in the United States. You have taxes on carbon where it's extracted from the earth, and then the money that's raised from that is given to as grants to poorer people in order to survive. But that's what I meant by saying that what we need to do is reorganize how society is structured rather than think that this is about transferring money from rich countries to poor countries. It's about rethinking how the world is structured politically and economically. So I don't want to deter you from finding your own pathway to reduce your own emissions. But I think we should all be aware of the fact that it can be seen as a diversion away by big business deliberately diverting us away from paying attention to them.
I agree, actually, because I'm a bit very hot on recycling, and particularly plastics is one of my absolute bugbears. But sometimes I do think I'm doing this, I'm recycling constantly, and is that actually making any difference? So yeah, you're absolutely right. It needs to be big business, and I think particularly supermarkets that produce so much plastic that I think is also obviously it's not climate change so much, is it? Or does the production of plastics impact on climate change?
Well, plastics are a byproduct of oil. So when oil, in an oil refinery, the oil is separated out into the kind of oil you can burn in your car, the kind of oil that is burnt in an airplane, and the chemicals which are used in pharmaceuticals and in agriculture, and plastics. So the feedstock for plastics comes from the oil industry, by and large, most of it. So if we reduce our demand for plastic, then we will be reducing demand for oil. And so that is potentially a good thing. So, but you hit the point is to not buy things with plastic to avoid plastic products and plastic wrapping. It isn't so much about recycling the plastic because the damage has been done when it's been produced. And as you know, most of it is not recycled properly.
Or is not possible to recycle. Okay.
Yeah.
Thank you, Terry.
There is a question from Jennifer in the chat box. Jennifer, did you want to ask your question or do you want me to read it out?
Okay. Yeah, sure. Thank you. Yeah, thank you for the talk. Very interesting. I just wanted to know your views about the UK net zero strategy. That I feel it's very focused on technology, but yeah, I wanted to hear your views.
I'm not getting you very well, Jennifer. What did I think about the what?
About the UK net zero strategy.
The UK's strategy.
The net zero.
The net zero strategy.
Britain's net zero strategy.
Yeah.
Well, I don't monitor it carefully because I focus mostly on countries in the global south, but I think I'm not very impressed by it because we have this coal mine which they want to open up. They've just stopped subsidies for house insulation and so on. So I mean, I think it's might have some good aspects in it, but a lot of it is not severe enough. It's not deep enough. But I can't really talk on it very much because I haven't studied it properly, Jennifer.
Thank you.
Great, thanks, Terry. Many people had to leave, but left their thank yous for an amazing lecture in the chat box for you. Being in the middle of the day, people were like, "Oh, I've got an hour for lunch. I'll watch the lecture and then have to dash off to another meeting." So that's the way that it is. Does anyone else have any other questions while we're here? No. Okay. I just wanted to quickly check with Terry what you mean by salinization, just to make sure that it corresponds with what I think it is.
Okay.
So is it just where the salt encroaches and the fresh water becomes salty, whereas before it was fresh water?
Yes, that's right.
Okay.
Do people want the slides? Because I need to make it into a PDF quickly. If anyone wants the slides.
Terry, if you send me the slides,
yes,
we will share them with the class of 2020 in an email with a link to the presentation as well.
That'll be great. Okay. Yes, salinization is where what is normally fresh water gets saltier, and and it is in different degrees. I mean, it can go from, you can taste slightly the salt to the point where you can't drink it and stay healthy. And that depends on a whole variety of factors that are putting salt into the water. So the water may be in the groundwater at different depths, which is what people tend to drink. But there's another problem where you have storms which push salt water from the sea onto the land. So if you have a hurricane, a cyclone, then that pushes the sea onto the land, and the land becomes salty and not suitable for farming for a few years.
Okay.
So there's the two basic salinization problems. But in the deltas, the salt is penetrating inland from the sea, from the ocean, because generally speaking, the complex interaction of factors, only one of which is human-made sea level rise. In many deltas, the problem is because the rivers coming into the delta are controlled upstream, sometimes by other countries, and so if fresh water is not coming down the river, then the salt water pushes further inland.
Yeah, that makes sense. There's a whole conversation here probably about whether or not water trading is helping or hindering with adaptation strategies for water. There's been a lot in the media over the last couple of days about how investors are really seeing a future in water trading, which in place, especially, but not in traditional kind of places where you might see that, where you think of water as being really restricted, but increasingly in the States, for example, over the last year, since California had its wildfires, the Wall Street is now trading since December in water futures in these states as well.
Yep.
So,
yep, utterly disgraceful. Yep.
So I'm always surprised. I don't know why. Every time I'm surprised, I'm like, oh yeah, people do trade in food. Oh yeah, people do trade in water. Why have we got, an imaginary marketplace for things that, should be readily available? Always surprises me. Yeah.
I know it is shocking, but that's because we've chosen to be at IDS, and those people have chosen to do an MBA and live a different life. And the worry is that on our campus, there are people being trained to do those things. So,
yeah.
We've got people in the business studies and economics who are being trained to do exactly the wrong thing. And so if we're to deal with these issues, we can be as virtuous as we like in IDS, and those people are far more powerful. I use a concept called the cure to damage ratio, which is not, it's not a very optimistic thing. The amount of money we have access to cure a problem compared to the amount of finance which is available to cause more damage. And actually, much of what we do is pretty irrelevant in terms of the much greater power that those with enormous amounts of funding have to make the earth a worse place. And so I think actually, if IDS is serious about thinking what climate change should be thought about, and development studies should be thought about, we should be thinking about, well, where do we place ourselves in this? Are we just a band-aid, or are we actually really challenging the way the earth is, the economy of the world is run?
As I say, so it's just a surprise sometimes. I think that it's everything just kind of connects, and until you start thinking about it, it didn't really strike me as a way that it connected particularly to the issues that people are now starting to talk about, because we've got COP26 coming up in the UK, and
yep.
all of these things, all of these things are impacts that you don't really think about until it pops up.
Yep.
Yes, anyone else, any questions or comments? Otherwise, I think we're probably about done. I haven't been keeping an eye on the time, but yeah, it's 2:15, so.
Hello, Roland, nice to see you there. All right, Good. Anyone wants to, they can always email me with other comments or questions. And you'll be able to
Thanks,
share
Terry.
the slides and the recording. That's great.
Yeah, I will do.
All right.
Perfect. Okay.
All right. Thanks a lot. Bye, everyone.
Thank you, Terry.
Thank
Bye.
you.
Bye.
Bye.